Hi, my name is Colin Brochard and I'm a data scientist with an interest in recommender systems. So for my project, I built a route recommendation engine based on data collected from mountainproject.com. Motivation for this project is that Mountain Project collects a lot of data, but they have about 40,000 users and about 100,000 routes. But it's difficult to navigate to and identify the best routes. So the objective for the study was to identify the most popular and the highest quality routes and provide personalized recommendations to climbers based on their preferences. And lastly, I wanted to build an app to help climbers discover the routes that they enjoy the most. So a quick overview of the project. I scraped data from the web using Beautiful Soup and dumped the data into a Mongo database. I used Pandas for the analysis, and I used the surprise library to do modeling. And lastly, I implemented the data into a Flask app. So the key to this project was parsing out the explicit ratings that each user gave to each route. This allowed us to model users' preferences based on the ratings they'd given, and allowed us to predict the climbs that they hadn't done yet. So what does our data look like? Here we can see that we can model our data as a sparse matrix where the values are the ratings that each user is given to each route. And so our goal with our recommender is to fill in the missing values. So what approach should we use? Here we have a huge matrix. When we multiply 39,000 users by 87,000 routes, we have about 3.4 billion cells. And we only have 1.6 million ratings. So that leaves us with a really sparse matrix. So the two most ubiquitous types of recommender systems are content-based and collaborative filtering recommenders. The content-based recommender system focuses on the characteristics of each user and each item, whereas the collaborative-based model produces recommendation based on the knowledge of the user's attitudes towards each item. And it happens to handle sparse and large matrices really well and allows for quick on-demand recommendations, which is perfect for our app. So one important thing to note is the distribution of the ratings is important. If you don't have a good distribution of ratings, then it's hard for the model to pick up on what the user's preferences are. And so you can see here on the left that we have a good distribution of ratings. And then on the right, you can see that in line with our intuition, routes that have low star values don't tend to be rated very often, which has some interesting consequences. So one issue with all recommendation engines is the cold start problem. And that is that when routes and users don't have many ratings, it's hard for the model to pick up on what the user's preferences are. So what can we do about that? So to address the cold start problem, I set a user threshold. And as you can see from this graph, as we raise our user threshold, the performance of our model improves. Right? We get a lower root mean squared error, which is basically the difference between our predicted score and what the users actually rated. But from the green line, we can also see that we lose the proportion of users that our model will work for. That being said, we still can provide aggregate recommendations to users under the threshold. So I set my bar pretty high at 10, a cold start threshold of 10 for users. Our root threshold, interestingly, as we raise our root threshold, the performance of the model doesn't seem to improve. And that's perhaps because the lower rated routes are found in that region where we don't have many ratings for them. So by cutting them out of our model, we might be losing valuable information. That being said, I didn't want to include routes that had 3 or fewer ratings because I felt like we didn't have good information about these routes, and I definitely didn't want to include them in my top 10 recommendations, so I excluded those from our model. So how did we do? Well, we achieved a root mean squared error of 0.62, which is pretty good. You can see here from the line plots that our true ratings and our predicted ratings trend nicely together, and we especially have good separation in 3 to 3 to 4 star region, which is important for a top 10 recommender. But that's good in theory, but does it really work in practice? So here's an outline overview of what the app would look like, and to test it, I put in my personal user ID and queried routes in California, which is my home state. And sure enough, the recommender has turned back a few of my favorite routes in California. And in fact, I've discovered a few routes that are definitely on my to-do list. So I'm excited about that. So next step, I'd like to do some more tuning and diagnostics to ensure that the recommendations are in line with users' actual preferences. I want to dig in further to figure out exactly what the recommender is picking up on. And lastly, I'd like to dive into the comments and the descriptions to associate some keywords with each of the routes, which I can use to create some interesting additional filters to the app. So if you have any questions or want to reach out to me, my contact info is up on the screen. Thank you.